To solve this equation, we began by subtracting 1 from both sides to isolate the radical. Because once it's isolated, we can square both sides to eliminate it. So let's square both sides to eliminate the radical. On the left side, we end up with 3x plus 1. On the right side, we end up with x minus 1 squared. It helps to recall the formula for this binomial squared, the difference of two terms squared. It's a squared minus 2ab plus b squared. Applying that to this binomial square, we have x squared minus 2 times this times that is just 2x. Plus b squared is 1 squared. 1 squared is 1. So that's a quadratic equation, which we can solve by getting everything on one side of the equation, the other side equaling 0. So let's subtract 3x and subtract 1 from both sides. The result is 0 equals x squared minus 5x plus 0. That's x squared minus 5x. So we can factor out an x from that, x minus 5 times x, because x times x is x squared, x times minus 5 is minus 5x. So this is equal to 0, which can occur when x is equal to 5, or if x is equal to 0. So these are both possible solutions, but we have to check them. We have to check each of them out to make sure they satisfy the original equation. First, let's check x equals 5. So we have 3 times 5 plus 1. Under that square root plus 1, we wonder, does that really equal 5? Well, this is the square root of 15 plus 1 is 16. And that's 4 plus 1, that is 5. So this is a valid solution. X equals 5 solves the equation. So let's try the other possible solution, x equals 0. See how that changes things. So now, plugging in x equals 0, you have 3 times 0 plus 1 plus 1. We wonder, does this equal 0? Well, this is the square root of 1 plus 1, and that's 1 plus 1, which is 2, and 2 does not equal 0. So this is not a solution. So we have to eliminate this one. There's only one solution, x equals 5, to this radical equation.